Hey, this is Reuven, and I'm back with another problem that one of my readers has submitted. Bill has written to me. Here, let me read his problem to us all. So we recently ran into a problem where we wanted to keep track of some global metadata, which meant that updating the global metadata across several different modules. But the problem was the separate modules couldn't see the globals for the overall program. So after a deep dive investigation, we discovered modules don't share the same global scope. Also, we discovered a module called Builtins, which for some reason was able to be seen by all the modules. So we stuck our metadata dict into the Builtins globals and kept it updated across modules. So my question is twofold. What's the recommended design pattern for sharing global metadata across different modules? And the second question is, what's really going on with this global scope anyway? What's the deal with Builtins? How can that module share global scope and another cannot? Okay, so what we're talking about here is scope in Python, variable scoping in Python. And this is one of those topics that I can just rant about for long periods of time. So I'm already warning you, this is going to be a bit of a long video, but I think it'll be worth it because it'll explain what's going on. So here's the thing. Let's first start off with, I'm going to start with a little program here that I've written. All right, as you can see, it's a very long, exciting program. And if I say here x equals 100, print x equals, let's use f strings. So let's do f strings now, x. Okay, so if I run this thing, let me just run it here. Was that where I've written this thing? I just wrote it on my desktop. All right, so now I've got that running on my desktop. Now let's just bring over a terminal window. All right, and now I'm going to run this. I'm going to say scope.py, and sure enough, the program prints x equals 100. Now, this is probably the most obvious, the simplest program that you're going to see, like that I'm going to show you now, but it also is a good gateway to understand what's going on. So what is happening here? We say that x equals 100. What does that mean when I say x equals 100? And most programs will say, well, duh, it means that you're defining the variable x to be 100. Sort of. What it means is I'm defining the global variable x to be 100. Now, there are a few different parts of this. First of all, remember that it's important to understand that if I'm not entering a function, I'm not creating a local variable. Many people think in Python, for example, if I do this, if I say like, if x equals 100, then, y equals 20. And they somehow think that because it's inside of indentation, because it's inside of an if, that, well, y is a local variable. They also think that about for loops. So if I say here for I in range 5, print, I don't know, if I say here, y equals 20, or y equals 20 times I, right? So if I do that, they think that either I is local or y is local. Neither is true. These are global variables. So that might be the case. So we've got global variables here, but global variables in Python are not as global as you might think. Global variables are available within one file, which means I can declare, there's no way to declare it really, right? But I can say that x is a global variable as much as I want, and I and y for that matter. All these are global variables. But there's no way for another module, another file to see those global variables without doing a little bit of work. Now, this goes against a lot of the ideas of global variables that you might be familiar with from other languages, right? So if I, in other languages, define a global variable, if I say that x is global, usually through some sort of either funny character or declaration, then I can just use x as a plain old name from wherever I want. But watch this. If I say here, let's do, my file.py, let's just call that user bin and Python 3.6. All right, so now I want to use that x that was defined in scope.py. So how am I going to do that, right? So people realize, I guess Bill realized also, I can't just say like print, right, let's do here f x, well, let's say, x equals x. Sorry for that bouncing stuff at the bottom. Python's going a little crazy on my computer here. All right, so print f equals x. If I do that, obviously there is no global variable x defined. It's just not there. So how can I get it from scope into here? Well, you're not going to like this. I'm going to say import scope. And when I say import scope, what I mean is I want Python to go and load a module named scope. And modules are just files in Python. So import really does two things. It loads up that module, it looks for scope.py, it reads through and executes every line of scope.py, and then it creates a new variable called scope of type module. That is a data type in Python. And here's the important thing. All of the global variables defined in scope, x, I, and y, let's just call it, will then be available in my file as attributes. So watch this. I can say here, print dir of scope. All right, now dir of scope is going to give me back a list of the names defined in that scope. If I go back now to here, I say here, myfile.py. Look at what I get. Oh, name X is not defined. Sorry. Let's get rid of this for a moment. I just demonstrated what I was trying to show. And we see here that we have, look at what dir returns. It's a list of names. At the bottom here, we have I, X, and Y, the 3 global variables defined there. So scope defined 3 globals, but they're not really global, huh? We can't really use them directly from my file. Right, we have to go through the scope name. If I want to print the value of X, I have to say here, scope.x. X might be global inside of scope.py, but X is an attribute on scope, on the scope object inside of other files inside of my file. So, if you define a global variable inside of a module somewhere, you can get access to it, but you don't get access to it as a variable. You get access to it as an attribute on that module. Now, if you really insist that you want to have as a variable, you can. You can say from scope import X. And now, actually, scope will not be defined as a variable at all. Rather, X will be defined as a global variable now in our current scope. So I'm going to run now, and sure enough, we see X equals 100. Now, by the way, why do we see it printed twice? Because we see it printed once from scope.py, and we see it printed a second time from inside of myfile.py, which means when we say from scope import X, we are actually still running scope.py. It's not as if somehow Python is going and taking out with pincers just that X variable. Still, the entire module is running, and only that variable is then imported into our local namespace. By the way, if we try to import scope a second time, no matter how, from import or just import, then it will not actually run that file. Rather, it'll just pull up the module from sys.modules, which is where these things are stored. Okay, so part number 1 to my answer is, you might have thought that you could have global variables defined somewhere and then just use them everywhere, but you can't. And so a common design pattern in Python is to create a module in which you have all of your sort of combined declarations, your combined variables, your combined whatever you want to call them, data and or functions, and you just do an import to that. And then from there you could say, so if I want to say here, I don't know, our defs.py. So you can say, X equals 100. Let's just call it, I don't know, version equals 1.3 and author equals Reuven, and I don't know. Let's just call this. Let's just leave it there, right? So now I can say here, import our defs. I have this here in my file. And I can say print our defs dot author. In fact, let's just say this. Let's say here, print f string, right? We're using our defs version, our defs dot version, written by our defs dot author, right? And I can close that. And now if I run this thing, we're going to get here. See, oops, what did it not like here? Our defs. Oh, version helps to actually spell things correctly. There's a little pro tip for you folks. Spelling is useful. All right. And there we go. And now it works. And what you can imagine then is many different pieces of your code doing an import to our defs or something with a slightly better name. And then you can just use them. That is like a common way to do this sort of thing in Python. Now, you happen to stumble upon a really cool, interesting backdoor to doing things, which was built-ins. So what the heck is this built-ins thing? Let's go back for a moment and say dir, let's just say dir of our defs. And let's say dir of scope. So now we're going to print dir of our defs, printer of scope. So I'm going to print out the directories of both these, meaning all the attributes there. And what do we see? Scope. Okay, they did a from import. Haha. Let's do an import scope. Just have fun here, and then I'll say scope.x. You'll see where I'm going with this in a moment, I think. All right, so if we do a dir of these things, you will see that indeed built-ins is an attribute on every single module. And so what is this built-ins thing? So built-ins is a module. It's a module that comes with Python. When I said before, how is X going to be found? Now let's just go back to scope.py for a moment. All right, so when I said here, X equals 100, we've defined it to be global, and then I say print. So how's Python going to find this value of X? Well, it searches in a standard way, L, E, G, B. These are the 4 levels of scoping that Python will always search for. The local, enclosing function, global, and built-in. Now, we're not going to talk about the first two because we're not dealing with functions. If you're not dealing with functions, the first two just disappear. So Python will always look first in the global namespace, as we saw before. But let's say it does not find a name in the global namespace. What's it going to do? It's going to look in the built-ins namespace. And that built-ins namespace has many, many aliases. What are those aliases? All that dunder built-ins inside of every single module. So every module that you have in Python has built-ins defined there so that everyone can just sort of go in and look through there for names. What is defined in built-ins, by the way? Things like int, str, list, sum, len, all the things we know and love and use every day that are not keywords in Python, but that we need all the time. All the exceptions, they have to be in built-in so that we can find them easily, so that we can raise them and do an except for them. So built-ins is sort of Python's repository of built-in stuff. And always, 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 you can Python will search first in LEGB, local, closing, global built-ins, but if you don't have functions, just in globals, then built-ins. So can you define something in built-ins and make it available elsewhere? Yes, absolutely. Because if you define something in built-ins, your built-ins points to the same module as everyone else's built-ins. So if I, for example, say here, let's do this. I'm going to say here, built-ins, I always get that wrong, dot, greeting equals hello. All right, so I'm going to add that there. And then I'm going to go back to, get rid of our defs. I'm going to go back to my file.py. I'm going to say here, let's get rid of this. And I'm going to say print greeting. Notice, Python, this looks to us like I'm trying to get a global variable here, but what's really going to happen? Python's going to look for it as a global, discover it's not global, discover in built-ins, and print its value. Let's see if that works. And no, it's built-ins, not built-in. I always get that wrong. I told you before, right? There. There's no actual greeting. Oh, sorry. Built-ins.greeting. So now it looks like actually Python is getting a little stricter on that. I wonder, so maybe he was doing it in Python 2. I guess in Python 3 you're not really like allowed to just sort of go messing around with built-ins. I sort of thought you could maybe. I wonder, yeah, I guess you're really not, well, you're not supposed to do this, right? And by the way, what we get here is dict object is no attribute greeting. I'm going to guess then he might have done like some playing around in other ways. This is, though, folks, a really, really bad idea. Built-ins is supposed to be defined by Python, set by Python, used by Python. Let's just see. It's actually saying here, dict is no attribute greeting. So it's looking for, why would built-ins be a dict? Okay, fine. I'm going to have to look through this a little more. The bottom line is, though, built-ins is Python's sort of last resort namespace where it looks for things. You don't want to be assigning to it. You don't want to be messing with it. Because if you do, all sorts of bad things will happen. Let me just give you a fun little example here. Let's say, mylist.py. I'm going to do here and Python. Actually, I know that you can play with built-ins. What happens if I say here, print list of ABC? All right, so I'm going to now run this, my list. All right, so if I run print list of ABC, what's going to happen? List is going to run the string ABC, create a list ABC, and we're going to print it. Okay, great. What though happens if I say list equals 5? Well, you might think, oh, you can't do that in Python. Aha, but you can do that in Python. Why? Because we have to keep consultants employed. And there's a great way to ensure that consultants will have job security. No. It's actually, I'm guessing, because we want to keep the parser relatively simple. And so as a result of keeping the parser simple, we want to, we'll just keep a lot of things in built-ins. Now, when I define this list, what am I really doing? I'm saying I'm creating a global variable list. So it's not like I'm removing the built-in version of list that we know and love. I'm just saying, well, if Python's going to search LEGB, and again, we're going to ignore the first two because we're not inside of a function. So now when I say list of ABC, what's Python going to do? Well, it's going to look for global. Is there a global variable list? The answer is yes. It's going to try to execute that darn thing, and oh, bad news. It's going to say int is not callable. Well, why? Because it's not smart enough to say, oh, you wanted to use the list from built-ins. No, it's not smart enough. I could do that myself. I could say built-ins.list of ABC, and then it'll work fine. But like, no one wants to write code like that. So as a general rule, it's a really bad idea to use variable names that are the same as things in built-ins. And people sometimes make mistakes with that. In fact, in almost all of my courses around the world, people create strings called str, and lists called lists, and dictionaries called dict, and so on and so forth. Don't do that. Please don't do that. It's just going to mess you up. And so you can mess around with built-ins a little bit, right? So I can actually do this, right? How can I solve this problem? I can say del of list. And that means remove the name list. But I'm not removing the list from built-ins, I'm removing the list from global, and now everything will work just fine. What though happens if I say remove builtins.list, right? Let's get rid of this thing. Now what's going to happen? Well, now Python's going to say, I have no idea what you're talking about. Because I looked in global, there was no list. I looked in built-ins, there was no list. And so if anyone wants a discount on a copy of Python without list, write to me and I'll be happy to send it to you. No, obviously this is not the sort of thing you want to be doing in your code on a regular basis or even an irregular basis. So bottom line, Bill and others, first of all, don't mess with built-ins unless you're teaching a class and want to have a lot of fun. Number two, if you want to have things that are common to everyone, the standard paradigm in Python is create it as a module, and then you can just do from import from that module to get those things if you really want them to be in that namespace. Better, I think, my personal opinion is, to keep it as just a regular import statement, not from import, and then you'll have the names hanging off of as an attribute from the module. That's not the end of the world, it's not beautiful, but at least it'll be very obvious where things are from. One last little point. A lot of people will tell you to do from whatever module, import star. I beg you not to do that. From import star is just a bad idea because it can clobber things, especially if you do it with multiple modules, just a bad idea. Don't do it, even though it's possible in Python. Much, much better to do from import, and again, with like pincers, pick out what you want. All right, Bill, thank you so much for this amazing question and an opportunity for me to talk about scoping, one of my favorite topics in Python. I know, everyone needs a hobby. For submitting this question, you get 30% off any of my courses or books, including the upcoming weekly Python exercise cohort starting in January, if you're interested. Other things are also good. If you have a question that you want me to solve having to do with Python, send it to me, Reuven@LearnersCoil. That's my email address. Every Monday, I send out new messages to my Better Developers list. I'll have links here under the video. And of course, weekly Python exercise starting in January. Very exciting. We're going to be doing lots of really cool exercises to beef up your Python skills. If you want to learn things, if you want to have office hours in which we go through things in this style, I'll be once or twice a month doing this sort of office hours, as well as sending you lots of email, as well as giving you exercises, as well as in a forum. Lots of fun for all to be had. All right. Thanks again, Bill. Thanks to all of you. And I'll be back soon with another problem.